What I have here is a demonstration of Young's double slit experiment. So I have a green laser here and I don't know its wavelength. That's what you're going to be working out. So I have a pair of slits and then a distance away, and it's actually 95 centimeters from the slits to the screen. So that's the distance big D. And then we can actually look and see the individual bright and dark patches that we call the fringes of the interference pattern. Now, probably you can't see it terribly well live, so I'll put a still photo up there to get a close-up view. But what you can, I hope, see, at least in the photo, is that we have evenly spaced fringes and they're brightest in the center, but they're not getting uniformly dimmer as you move out. What it seems to be is that it's brightest, then you've got a darker patch each side, and then it gets a bit bright again, and then a bit darker again, and then bright. So what you're actually seeing is the interference pattern from the two slits combined with the diffraction pattern that comes from the actual size of the slit, and that's what we're going to be talking about next week. But for this week, we're just interested in these evenly spaced individual bright and dark patches called the fringes. Now, there are two versions of the equation for constructive interference. One lets you work out the angle. The other lets you work out the spacing between fringes. And as you can see, when it comes to actually doing it, the little y, that is the spacing between fringes, is a lot more easy to measure than trying to get an estimate of theta from measuring distances and doing it that way, because theta is extremely small. So this is 95 centimeters. The slit spacing is so small I can barely make out that it's a pair of slits. So clearly this distance is very, very much bigger than the slit spacing. So we use the approximation that we'll just go with y, that is the distance between the bright fringes. So in the central patch there are actually 5 different peaks, and the distance from the first one to the 5th bright fringe is 16 millimeters. And so you'll be able to work out from that, because they're evenly spaced, you can simply work out from that the spacing between adjacent fringes, that would be the m equals 1 to be substituted in the equation.